Hey everybody, this is Larry. This is December 11th, where I will do an extra bonus problem that I haven't done before. It is Sunday and I am doing a little bit earlier in the day, so I'm going to try to do a hard one and get it out of the way. Let's do a random. Okay, so today's problem is $4.99, the maze 3. It is a premium problem, so if you don't have premium, my apologies, but hopefully, you can read the screen and then we'll do it together or something like this. Okay, so there's a ball in a maze with empty spaces and was, okay, so, okay. Empty spaces are 0, 1s, and then you can go up, down, left, right, hit the ball when the ball stops. You can choose the next die. Okay, so we can go through empty spaces by going right or up, down, left, right, but cannot stop, and so it can and only go to a stop and then it moves. Okay. There's also a hole in this maze, and you're trying to drop into the hole. Okay. Why do you have a soccer and a golf thing? That's just a little bit lazy on the story. Okay, so given in this maze, that's given this maze, the ball's position and the ball's position hole, return a string of all the instruction that the ball should follow with the shortest distance possible, and you have to do a lexicographically minimum one. Okay. So I mean, there's a if not right, impossible. Okay. Distance is the number of empty spaces traveled by the ball from the start position to the destination. Okay, so I mean, this is going to be Dijkstra just because. I mean, you could do it two ways. I don't know which one off my head. I mean, we might have to look at the constraints a little bit. But you could do it. This is clearly a shortest path problem. You could do it with Dijkstra. You could probably do it with breadth first search. The complexity is a little bit unclear without looking. I mean, or at least I know the complexity, but it may just be too slow. So we might have to take a look at it. And then the other part of this is that it is the shortest path, but with the path reconstruction, especially caring about the lexicographically minimum one, which is actually a little bit tricky because usually with path reconstruction, I have to think about this a little bit, because usually with path reconstruction, the easy way is to go backwards, but in this case you might have to go forward and then do a simulation. But yeah, overall, I think the concept of this problem is not super hard, but it is one of those problems that is going to be implementation heavy, and this is just from experience, where there may be quite a few edge cases that we have to take care of. So, so yeah, I don't think there's anything that tricky, so let's kind of jump straight into it. Let me look at constraints real quick. R times R and C is equals to 100. That means that, and if there always okay, so R and C is equal to 100, so that's 10,000. That means that so you cannot do breadth first search then, because in theory you can visit all the states. I mean, you could. I mean, the worst case is like a SNCC like type thing, but that's still a lot of state to do, I think. Even though it would be, so the advantage is that it's easier to implement and the proof is a little bit easier. But yeah. Okay. The maze will contain at least 2 empty spaces. Okay, Okay. Yeah, I mean, this is just way annoying to do, but let's start. Yeah, okay. So now for x in range of O, for y in range of C, we basically want to do start y, and x and y is equal to -1. Oh, I wrote this way, but and then here, if maze of xy is equal to, oh, they give you the ball. Whoops. So I didn't have to look for the ball. For some reason, I thought I might have to look for the ball. So okay, so it goes to ball ex ey is equal to home. Okay, and these are 0 index. Just double checking. Okay, good. Okay, so then this is just Dijkstra. So let's set up a heap. Yeah, this is just gonna be annoying. It's not that bad though. And then let's have an enqueue function. Trying to think about what's the best way to represent an edge. Is it simulation? Simulation might be okay. Meaning that, let's say we have a board here, right? And we have this map. If we want to, so the way to do it, so with breadth first search, you could just go like, up and left or right or whatever. But with Dijkstra, what you want to do is simulate going from here all the way to the top. And that'll take, But then now you're just doing a for loop of 5 elements, right? And the problem with that is that you do get repeats, maybe, if other stops are. The modeling is a little bit tricky. Can I do brief breadth first search? I mean, if it's fully empty, then you get in 200, or maybe even 2. Because you have to count the space. Wait, is it? Let me double check. Shortest distance possible. What is distance? It's the number of empty spaces. Okay, yeah. Because it's not the number of directions, it's the number of empty spaces, right? So that's the kind of a tricky part as well. Is left, up, left. Up, left. This is so annoying to do, actually. I mean, no, that part is fine, but I just have to figure out if the simulation is okay. I guess we'll see. I mean, at first we'll just have to optimize this, but yeah. I guess we need a D for the distance, and that's pretty much it, really. And then we have to do a distance, right? I'm a little bit lazy. I need to be, that's a bad habit, I think. But anyway, okay. So then, yeah, we're in Q, where the boys, or SXSY, and then now, this is just regular Dijkstra stuff. Dijkstra? I always call it Dijkstra, but sometimes people correct me. I never know anymore. Okay, and then of course we need directions. Yeah, okay. And then now, basically, for each of those directions, we go nx ny is equal to xy. Okay, while plus dx is and then nx. Basically, we just keep on moving if we can, and then now that it goes out of bounds in the next time, and we have to check that is equal to 0 for spaces, right? Okay. And then now nx and y is in a good place. So then what are we doing? Sorry, I got a little distracted. Yeah, so then now we, sorry friends. Yeah, now we just put it in, right? So we should probably, so we assume that the space that we're currently at is whatever, but yeah, so then now count is 0 to 0, let's just go to count, doesn't matter. And then we move one empty step. I have to double check that this is okay versus like an off by 1, but that's fine. And then now we unqueue it. Oh, and I have to set this to 0, obviously. Nx and y and d plus count, but only if we want to. Maybe we could put in the function. Okay, so maybe we just call it maybe nq, right? And then here we can put the if statements here, so that if xy not is in distance, so it's here and the distance is already smaller than d, then we return, right? Otherwise, if it's not in there, then we do it, and then yeah, I think this is okay. And we assume that this is already in bounds and stuff due to this while statement. And of course, it's the comma. If nx and y is just equal to xy, then this would already have a distance anyway. So, oh, and this is actually, if it's equal to, we also don't want to enqueue it. So, okay. Okay. So we return impossible. Otherwise, yeah. We have to do some other work first, but I want to at least get to a place where I just want to take a look to see if, sorry, typing. I just want to at least take a look to see if this is at least on right, or if we have to debug it, then you know we have to debug it first. Whoops. See, versus like writing more code and then debugging. Did I not set this up? That's weird. I didn't even declare a thing, but it gave a different one, a thing instead. Okay. So it's outputting impossible. We knew that, but that means that we didn't get. Oh, well, yeah, of course, because it's impossible, so that's accurate. Wait, is it? Did I misread that one? Let's see. No, this is not impossible. So, oh wait, no, I mean it's fine. All right, let's just return 10, so that we know for more clear. So okay, so it's still giving me impossible for some reason. And also I forget that here if distance of xy is greater than d, we continue, so we don't process the same node more than once if we enqueue more than once. Okay, but that's weird, but let's see. Let's print it out. Okay, so it is doing something. So it starts at, where do we start at? We start at 4.3, and then we go to 4.4 as one direction, 0.3 as one direction, 4.2 as one direction. You can't see me, but I'm just, wait. Oh, the grid here is because the borders of the mazes are all walls. So it's not in the grid. Okay, so 4.3 is actually here. Okay, 4.4. 03, 42, 02, but not 01. Oh wait, because it would drop through the hole even though it doesn't stop at the hole. I see. Okay, I have to add a thing for it. That's fine. That's actually, see, lot of edge cases I didn't even know about. But we have to add something to here, but I think that's fine. I also should have printed, not here, but I should have also printed the distance, but I think that's fine. I think that part is not that bad. So okay, so basically here we wanted to stop if nx and y is equal to ex ey, right? So if ex and y ex and nx ey, then we want to break. So we want not of this, right? Is that right? So this is where we want to break. We want the not of this, which is, you know, modus total or whatever. Okay, so something like that maybe. Am I printing? Okay, so now I'm printing stuff. I'm printing the answer 6, which is that right? So 1, 2, 3, 4, 5, 6. So that seems right. What is case 3? Case, do we have a diagram? Case, no, just this one. I don't know the answer for that one, but can we? I don't want to draw it to figure out if this is right. I'm lazy. Okay, I mean, this is not that bad. I just am looking to see if I could figure this out, but I'm lazy. So okay, so yeah, I mean, it works for case 1 and maybe case 2. So okay, so that means that we're on a good track. So now we have to do the path reconstruction, which is kind of hard to do lexicographically, to be honest, or at least like not the usual way that I would do it. So the usual way that I would do it is doing it backwards, but backwards you can really do lexicographically minimum easily. But this one with the shortest path, you just have to give a little bit of thought, and the way to do it is just greedy, right? With lexicographically minimum, you just have to do the one that gives you the first thing. So let me rewrite this a little bit. Because basically we want to sort by, how do we want to sort by? D, L, R, U, right? So down, which one is down? Down is down on the Y, left is -1 on the X. Is that true? They don't, so 4, 3 is 4 down. Okay, so X is the negative first component. So that means down is actually 1, 0. Left is this way, and then right is this way, and then up is this way, right? I think, right? And then we can maybe do like, you know, L or D O R U, right? And then the idea here is just recreating the steps, basically. So okay, so if this is not in this, then we return impossible. Otherwise, then we just start from xy is equal to ex ey, or start x start y, whoops. And then here we just basically track which way is it to go optimally, right? So so yeah, let's just say d is equal to distance of ex ey, and then yeah, basically maybe we'll just do a while true. We do a path. I do a while true so that I could do random if statements to break out of it, but we'll see. Need more space so I could. So then now we go up, down, left, right. So for I don't know, I also want to do direction, so that's why I do it this way. And this part, maybe we can make a copy here. Let me see if I can. Okay, so I just say get n. I don't know, right? For xy dx dy, right? So then now we can do something like yeah, right? And then we return nx and y and count. I don't have any space. That should be okay. And then now we can just do nx and y is equal to get n x y dx dy, and also I forget the count. And then that's pretty much it. But before that, let's confirm that this is still working-ish, right? Okay, so it's working as before, I think. So this is good. Yeah. Okay. So then, how do I call it? Wait. Oh yeah. Okay. So basically, now we can do something like, okay. So here, right? And yeah, maybe current is equal to 0 as well. And then now, basically, the idea is that we just have to check, right? If the distance of nx and y, so now we have, so basically you're just counting, so nx and y is the middle point, right? So if the count plus this, so current plus count is equal to distance of, or d, the last answer, then we break, but we keep the index, right? So the good index, maybe g index is equal to index, and then we break. And then path dot append, we have to do some other stuff too, but let's path dot append, I forget, trs dot underscore. Autocomplete is always auto-completing except for when I wanted to. I don't know if I turned it off though, so maybe it did finally get turned off. We want to assert g index is not equal to -1, and also then now we want to update xy is equal to nx and y, and also current is equal to current plus count, because we move forward that many steps, right? Okay, and then at the end we just return we join the paths together. Don't know if this is quite right, but yeah. Oh, I forgot to enumerate. Okay, that's unfortunate. Maybe current is 0, count plus is equal to d. Did I mess up? Let's print this out just to see where I'm doing wrong. It should be only 2 things, really. Okay, so this is working on the first one. Let's print it out then. X and Y count. So XY, it may be right. No, let's just print everything. How did that happen? So it looks at all 4 directions, right? So D is 6. Distance of n. Oh, I did it the other way, huh? Because this is the distance from the beginning, not from the end. So I messed up in what I represent. I don't know that I can backtrack the other way, but okay. So I did mess that up. Let me think whether I can. Huh. I messed that up actually a little bit. This is the distance from the starting point, not the end point. That's why, for some reason in my head, I got that this is the distance to the end point. And the problem about this part, or the tricky part about this problem, is that it's not symmetric, right? It's asymmetric, meaning that you can't go backwards the same way because, well, you just can't because you hit walls and stuff like this. So I have to think about how to, you know, whoops. Can I do that in a good way? No. Also trying to make sure that I don't, do something exponential by accident. And of course, like there are ways where you can draw the back edges from here and then, redo it the other way. But that's just messy. Let me think if I can think about it different way. So this is the distance from the end. Okay. But that's the distance from the beginning to that point. Sure. So that means that this count will always be equal to this, which is not useful. Yeah, my unfamiliarity is because usually I do path reconstruction the other direction, but the lexicographically minimum is kind of messing me up a little bit, to be honest. How would I do that then? Without like really, I mean, I know some ways of doing it, but I'm trying to think of a way that isn't really annoying. So let's say we have the previous. Then what? Because you also don't want to update all possible cases to reconstruct it, because that could be exponential or something like this. Maybe. I mean, I guess you could draw because then you could create a second graph, or like there's an implicit second graph on the back edges, and then you have to do another traversal or whatever. Yeah. Man, wow. And that's just, I mean, I could do it. Just try to think about ways to not do it. Okay. Let me think. I feel like we made good progress though. This is from the start. So we want to go key. Yeah, maybe that is the way to do it. Yeah, okay, fine. Okay, fine. I mean, I guess it is what it is. This is really annoying. Okay. XY. Oh, now I need the previous X and previous Y. Whoops. This is annoying. XY. Okay, fine. Otherwise, previous of XY is equal to just okay. And basically, this will just allow us to kind of do backwards with the path construction. Yeah, so I mean it'll fail, but I just want to see. Okay, so we how do I get -1? -1. 4, 3 is to. Oh, I guess that's fine. But why does it have itself? Oh, because it went down. Maybe. Oh, because of this. Yeah, okay. I mean, maybe that's special. But then now you have like these weirdness. Also, is what's 4, 2? So 1, 2, 3, 4, 2. It shouldn't have itself, right? Let me just add that here. Yeah, I mean, we could have dealt with it. It's just that that's way more annoying. Okay. Okay, so now I guess we're good with the previous, and then especially, you know, even with the multiple ones. This is really annoying. As I kind of expected, but I didn't think it would be this annoying. Okay, so then now we start xy is equal to exey, and then we can just go backwards, right? So then now we have a queue. I guess I can't. Usually you don't need a queue, but because there's multiple paths, we need a queue, almost like a breadth first search. So yeah, so now we want to basically have a second distance. That's distance from the end. Yeah, whatever. Just call it distance 2 because I'm lazy. And then basically distance 2. I don't need to do it this way. Okay, fine. Let's do another maybe NQ2 of xy, which is if xy in distance 2, then we return. Otherwise, distance 2 xy is equal to d. I forgot the d. And then what did I say? Q it. And this is just breadth first search. So yeah, so we may be in Q2 of exey and 0, and then now we're going backwards on the previous graph, right? So while length of Q is greater than 0, xyd is equal to Q dot top left, and then now basically we just go through the previous. So previous of xy, right? So for nx and y in this thing. Do I need to? Oh yeah, okay. So then now we may be in Q2, nx and y, and then what's the d? Oh, d plus 1 because we're doing first search, and that should be good. Except for when it gets to -1, -1, but I think we can just ignore it maybe. Okay, right. So then now we can. Do I need the d? Wait, what am I doing with the d? So now we're counting the things from the frame, but I don't think that the d matters. We're just trying to look for it. We need to count. What am I doing? Oh my, Larry, what are you doing? I think we need it. Yeah, we just. What am I doing? Ah, jeez. Okay, so we do. So, I don't know. I think I was thinking of something else because I was trying to optimize the number of steps, but yeah. We actually don't even need the D at all, to be honest. Well, we need a D, but not this D. So we could do XY and then this D, and then maybe Q of from previous thing. So then previous X, previous Y, and then no D. What we actually want is the distance from, yeah, and we could figure this out, right? So it's, why, I forget which direction it goes. So it goes, because we reworded it a couple of times. So I'm just a little bit lazy. So we're just gonna do this, and then yeah. So this is D. Yeah, okay. And then now let's print out this 2. And I think all we have to do is just change this to this 2, because that's what my original intent anyway is. But let's print it out real quick. It's missing this. Okay, fine. Oh, let me just exey, because that's where the 0 distance is. But the -1 is the previous one. Okay, fine. We have to, if nx is equal to -1, continue, something like this. Yeah, is it in? Why would I infinitely loop this? Infinite loop is here. Oh no, I'm just putting too much. But it's from the infinite loop though. So that's a little bit weird. Did I miss something here? Actually, this should be a 2. So maybe that's the issue. That's good. I mean, maybe. At least we got past this stuff. And oh, I fixed this, but not that. Whoops. Okay. Huh? It might still give the key error, but what we want is, that means that there's no path to it. So then it means if nx and y not in this 2 continue, because that means that that path is not going to the shortest path. But that's upsetting. But I might have gotten this part wrong. So let's see. Distance of 2. Oh yeah, so these are negative, so I'm kind of messed up on the direction. I forgot. Like I said. But that's why I have a print statement there. Okay, so this is a little bit better, but still not right. Okay, so let's go back. So 0, let's look at C, this is right. So 0, 1 is 0, 0, 3 is 2, 0, 2 is 1. Oh, yeah. 0, 2 is 1, 4, 3 is 4, 4, 2 is 4. Wait, what now? 4, 3. This distance is wrong, isn't it? No, it's 2 plus 4. So this is, it has to be, okay, so I do need the D in here somewhere. Okay, fine. Because it just takes the distance, but not the total distance. So then I can't do this the way that I there's a lot of coding on this one, so I'm messing stuff up, but it's okay. We're making progress. Sometimes it is slower. Let's see how we're going to fix it this time, Larry. Okay, so I guess, let's just go back to doing it here and having this put the D. We do, and this is 0. We get the D in here. If this is on a thing, then we have D plus what is this thing? Okay, so D plus this thing, so I think that's fine. Except for previous is now XY, and this is the new one. Oops. run it again real quick. Hope the debugging kind of makes sense. Yeah. Okay. Well, this is now printing some weird stuff. So, no, you want n, x, and y. That's why. Hopefully, you're seeing Larry debug in real time, and hopefully that's kind of useful, but maybe not. Okay, so 4, 3 is 6. So I think now we're in a good place, but now we're trying to see what's going on. So it goes from 4, 3 to 4, 3. That's a comparison. No good. 4, 3. 0 plus 0 plus 6 should be good. Oh, D is 0. Why is D 0? Oh, no. Did I reuse D by accident? That happens a lot, shadowing. Okay, so that's good. So D is the distance. Oh, no. Oh, I confused it. So what I want is this, and then, because that's the distance, that's the longest distance, and then this is it, and then hopefully that's good. It looks like it's going in an infinite loop somehow, because we have a while true and we don't ever end. So when do we end? We didn't even consider that. So yeah, if x is equal to -1, we break, because I think one of the previous is -1. Maybe not. Maybe just sx and y is equal to sy, then we break. But we have to append the path first, I think. So I think that's fine. Because I think we actually filled out the -1 from here. Yeah, I'm waiting for it to finish so I could, this is a very tough problem to get it right precisely. And we haven't even, yeah, I know that it's, and we haven't even gotten, that to submit yet. It's just on examples. But this shouldn't be that long though. So, so if I'm running an infinite loop, that means that there's another issue. I just thought that, oh, whoops, it should be EXEY, because we're now going back again. I was thinking about going forward and then back and then, all these things. Apparently there's still some issue. It seems like it is not moving because things going down, by basically not moving. It's saying, and the reason why this doesn't terminate is because we filtered that out here, and we didn't filter out here. So basically, yeah, if x is equal to nx and y is equal to ny, we continue. Okay. So, like I said, a lot of edge cases, a lot of weirdness. Honestly, might not even be 100% done yet, but let's give it a submit. Oh, it is. Nice. Slower than a lot of people, but I do wonder if there's a cleaner way to do the lexicographically minimum part. Because I did it in a way, and I knew how to do it this way, but I don't know if there's a easier way. So I'm going to take a look at, see if there's a, is it just BFS? I couldn't prove that the BFS is fast enough, to be honest. I don't know if this is like a Python thing. I think the I knew how to do it this way, but I couldn't prove the upper bound tight enough, because you could keep on. I don't know. But and then on that way you can maybe, I don't know. To be honest, I don't know. But anyway, that's all I have for this one. This is Dijkstra. I mean, I use Dijkstra, so this is a very Dijkstra complexity. So yeah, which means that is, O of y log y, which is O v log y. Yeah, so I have O of v log y, which, I mean, v is the same as y in this case anyway, right? Because there's only 4 edges at most for each v. And in this case, so log v is the same as log y, kind of. So yeah, and linear space, we have just like a lot of linear space things. So yeah, let me know what you think. Let me show you the top. Let me scroll down a little bit, Then let me scroll you to the bottom and let me know what you think. The way that I did it is definitely very complex. Apparently you could do breadth-first search, but I wasn't able to prove the bound. That's why I didn't do it that way. You may recall that I kind of talked about it at the beginning. But yeah, overall, like I said, algorithmically, not a hard problem. Just a lot of weirdness that you have to take care of. A lot of edge cases and making sure that you're careful. That's all I have for tonight. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great week, friends. I'll see you later and take care. Bye bye.